Hi guys, welcome back to my channel. In this video, I'll be taking you through volume of solids. We've solved a couple of examples on this and I continue with this problem here, which is an interesting problem. It says find the volume of the solid enclosed by the planes 4x plus 2y plus z is equal to 10, y is equal to 3x, z is equal to 0 and s is equal to 0. These are four planes we need to find the volume enclosed by what? Enclosed by these planes. So how do we do this? We need the limit for what? Our integrations, okay? So generally the volume is given us. The double integral over the region of the function xy dA, right? Where d is our region, so our boundaries here will generate our d for us. So let's see. First of all, you have to make z the subject because we are in the double integral. We are not in the 3D, okay? We are in the 2D. So z is equal to a function of s of what? Xy, right? So I'll get 10 minus 4x minus 2y. As simple as that. Now we have other planes here, but to find the limits, we need to what? See the points where all the planes are intersecting. So I'll put z equals 0. And when I put z equals 0, I'll have 0 is equal to 10 minus 4x minus 2y. Therefore, I have 2x plus 4y to be equal to 10, right? Then x plus 2y will be equal to what? 5. Take notes. Or let me say 2x plus y is equal to 5. So this is our first limit point. So y will be equal to negative 2x plus 5. So meaning one of our limit points for y is negative 2x plus 5. The next thing to do is just for you to make y the subjects to know the boundaries. But we have been given this plane y is equal to 3x. So this plane itself also becomes another boundary. So we have y is equal to 3x to be another boundary. Okay. Now we have one boundary for x, which is s is equal to 0. Now to know the corresponding value for our y, what you do is you have to set s to be 0 here, right? In our function here. Like even with this, when we set s equals 0, we get y to be what? 5. Is that not it? So graphically, our planes can be drawn simply. Here, when you have 0 here for x, you have y to be what? 5. Is that not it? Y to be 5. So meaning if we are to draw our first plane, negative 2s plus 5, when s is 0, we get it to be 5. So this will be the first point of the plane, right? First point. Then remember that when I have y to be 3x also, and I put that y equals 3x here, right? When I put y is equal to 3x here, the same equation, I'll have for 3x is equal to negative 2x plus 5. And I'll have 5s is equal to 5, giving me s is equal to 1. So meaning the boundaries for x is 0 and 1, right? 0 and what? So here is 0 and here is 1. So meaning that our planes or our solid figure that will be formed cannot exceed the x-axis on 1, cannot exceed the y-axis at 5, right? So let's see. Now, when s is equal to 1, our y will be equal to what? 3. So meaning you have a middle 3 here, and that will be the end point for our line. Y is equal to negative 2x plus 5. Because this is a plane, and on a plane, the maximum you can get for x is 1, and that is giving us 3. The minimum is 0, and that's giving us 5. That's what we do. Then for the second part is y is equal to 3x. Remember that when x is 1, it's 3. So the maximum it can go is this point. So y is equal to 3x. At this point, this is the region we have supposed to find the volume of, right? The region. So on that note, we just straight away go to our integrals. Remember, x spans from 0 to 1. So the limit for s is greater than or equal to 0, less than or equal to 1. And that will be the outer integral. 0 to 1, the inner will be what? From the 3x is down, so that will come down 3x to what? Negative 2x plus 5, right? Our function is 10 minus 4x minus 2y, then dy dx. Take note, dy dx. As simple as that. So if you want to solve this, what do? It's direct integration. We want to integrate what? Our y first, and that will give us 10y minus 4xy, right? 10y minus 4xy, then minus y squared. Minus y squared. Our limit of integration 3x negative 2x plus 5. And we bring our dx here. Then we bring integral from 0 to 1. That's all. So at this point, after simplification with your limit points, you are supposed to get integral from 0 to 1 of the expression 25x squared, right, minus 50x plus 25 dx. Okay. So once you do this, you're almost done. When I integrate this, what am I getting? I'm going to get 25 over 3 s cubed minus 50 over 2 s squared. And 50 over 2 is simply 25, right? So let me clean it up. So 25 s squared plus 25x from 0 to 1. Okay, from 0 to 1. And this simply gives me, you see, 0 will make everything 0. So when I put 1 here, remember negative 25 and this one will cancel out. So I'll be left with 25 and 3. And that is the volume. So that is the end of this video. Thank you for being with me. Don't forget to like, subscribe, and what share.